Hey, what's up, everybody? Today we're going to talk about applications of exponential equations. And really, we're just going to talk about money. We're going to look at how to solve exponential growth and not so much decay, but we'll talk about decay problems as they kind of relate to exponential equations. I'll say, and this is how you make a decay, and then we won't look at any of those. But the two big differences between the two examples today are going to be, one is incremented, or another way you could say that is it happens discretely. It's like you wait a week and then it happens. And then you wait another week and then it happens again. Whereas continuous means it's just happening continuously, just like you would expect. So we will look at those two different types of problems today. We'll go over some vocab and we'll get you on your way. So the first thing we need to look at are the two different types of equations that you're going to be working with for this process. For the incrementally compounded, let's kind of talk about what we mean by compounded. What we're going to be talking about today is specifically interest and how different money accounts at different interest rates accrue interest over time. What that means is someone pays you for having your money in the bank. It's like you let inflation happen to your money. So there's ways we can calculate that. There are different ways banks or things can come out. Either they can happen after a set period of time and then we apply the calculation, or we can just let it go the whole time. So for incrementally compounded, let's say you have $5,000 and you put it in the bank and we'll give you, 1% interest. If we're compounding this incrementally or discretely, what's going to happen is, let's say it happens every month. So at the end of January, they go, all right, here's your 1% interest. So 1% of 5,000 is $50. So after January, you have $5,050. Then at the end of February, they say, all right, you need another 1%. Now, because we have $50 in there, we don't just get $50, we get $50.50. So you're going to be at $5,100.50. And then we can keep doing that, right? So then we do another 1% and then another 1%. But what's important here is that this calculation only happens one time per month in this example. That's what the incremental part is. It's not happening every second of every single day. It's on the 25th of every single month. The bank runs its interest calculating program thingy, and then you get your payment. You don't just see your money gradually tick up while you are logged into your bank account. You go, oh, let's sit and watch it grow. That doesn't happen, right? So that's incremental. It happens discretely. It happens a set time every so often. We can also compound things continuously. And you're going to say, well, you just said banks don't do that. That's because we can use this thing for stuff other than money. And there are things in real life where the value does change continuously. You could think of like the stock market, right? How do you spell market? Like that. So if you think about the stock market, if you look at the stocks when it opens in the morning, they're one price. And then throughout the day, your stock price will kind of hover and it'll dip. And then it'll come back up, and then, and then it kind of looks like this. But any time during the day, there's a different price. It doesn't matter what it was at opening bell. You have no idea. And there's not a set time where they recalculate the price. It's just continuously changing based on market demands and who's trying to buy stuff and who's doing what. So it's for things like that. You can also use this for any other exponential growth that happens continuously. This looks suspiciously like our equation from last lesson, where it's P of T equals P I forget. Anyway, it looks like yesterday's. It's basically the same equation. So cool. There's those. So let's go through and look at all these different variables that are in these two equations, and then we will do your examples. So in both these equations, we've got some common variables. We've got a, p, r, and t. A, p, r, and t. So let's talk about the common ones, then I'll talk about this n that's only in the incremented interest. And then if you want, we can talk about e, but it's not a variable. So a, I don't know that this has a fancy name or why we use a, but this is your final amount. Whoops, final only has one a, doesn't it? Whoops, come on. Final amount. See, I was trying to write the a for amount. That's what happened there. P is your principal. And it's not like the guy that runs the school. Principal is a fancy math word for amount you invest. So this is how much money you're going to put into the account to start with. You could think of it as your starting amount. The fancy math word is your principal. R is going to be your interest rate. But your interest rate needs to be a decimal. Let's write that in a different color. Must be a decimal. So they're not going to tell it to you as a decimal. They're going to say 7%. You have to change that into 0.07. Okay. If you don't do that, this equation, neither equation will work. So it must be a decimal. If it's not, you're in deep doo-doo. You're in trouble. All right, and then t is time. For all the problems you're going to do today, it's in years, but there are cases where it's not in years. But, you know, for this class, it's in years. Don't worry about the units so much. Okay, the last variable we have here is n. So these n's are the same n. They will be the exact same number in the equation every single time. N is going to be the number of times you compound your interest. Whoops, there's a second E in interest. Interest is compounded. So this basically is just going to tell you how frequently, that's a hard word, how frequently is your interest calculated. You could do it every day. You could do it once a week. You could do it once a month. You could do it every 10 years if you really felt like it, if you thought you were going to live that long. But n is going to be the number of times it is compounded. All right. Over here, these are all the exact same variables. Notice because it is continuous, we can't say how many times it's compounded because continuous implies that from here to here, there's infinity things in between. That's what continuous means. It means there are no gaps. So there's an infinite thing. So it doesn't really work out. E kind of takes care of that for us. And again, E is just Euler's number. And it's about 2.714. Give or take. It's a irrational number like pi that you can look up. So, all right. So let's talk about different words they're going to tell you to indicate n, because they're not going to be really nice and just say n equals 12, right? They can't just be kind to you like that. So they're going to hide it in these time words. So let's just look at them real quick so that you know them. So if they say daily, because we're talking about time in years, you want to think about how many times does this thing happen in a year? So there are 365 days in 1 year. So n equals 365 if you see the word daily. Weekly, there are 52 weeks a year. So n would equal 52. Monthly, there are 12 months. Quarterly, quarters are 1/4 of something. So if you want a whole, right? If you want a whole year, then you have to have 4 quarters. This is how most big businesses report their earnings. They report them quarterly to their investors. So if you hear like quarterly reports, this happens every 3 months. So January through March is one quarter, April through June is a quarter, and so on. So quarterly is 4. Semi-annual. Semi means like not quite. So it's like one thing before that. Annual means years. So the next smallest thing from a year would be half a year. So this is just half a year. Happens twice a year. Once in like December and once in June or something. And then annually or yearly, there's only 1 year in a year. So n equals 1. Alrighty. Let's go do 2 super straightforward examples. This is going to be a super easy lesson for you guys because all you have to do is figure out your, whoops, I don't want to write letters. Come on. We have to figure out our principal. We have to figure out our interest rate. We have to figure out n if it's compounded incrementally. And we have to figure out t. Once we have all of these variables by reading this problem, then we just plug them into the equation that we find appropriate and then throw that thing into a calculator and you're ready to pack it up and call it a day. So it says you invest $5,000. They just told you a variable. That's your principal because that's the amount you are putting in. That's your starting amount. So P is 5,000 into account whose interest rate is 2%. So there's our interest rate, but remember, we can't leave it as a percentage. We need to turn this into a decimal. So 2%, to turn things from percents to decimals, you just move the decimal 2 places to the left. So this is going to be 0.02. And it is compounded quarterly. So that means there are 4 quarters in a year, so n is 4. And now we want to know how much money would you expect to have after holding the account for 10 years. So we just put our 5,000 bucks in. They say you'll get 2% a year. We say, yeah, that sounds great. And then you let this thing just sit there, and 10 years later you come back and see how much money you have. So t equals 10 because we're going to wait 10 years. So now we just have to plug this in. Because they have told us compounded quarterly, we have to use the incremental equation or the discrete equation, the one where we have the n values in there. The continuously compounded equation, just we don't have the right information. It's not going to work out right. So we're going to use this equation. So our equation is A equals P times 1 plus R over N to the power of NT. So we're just going to fill in our numbers now. So A equals 5,000 times 1 plus 0.02 over 4 times 4, or sorry, not times 4, to the power of 4 times 10. Okay. When you are simplifying this, if you throw this whole thing into the calculator and you leave these parentheses here, it'll do it correctly for you. But I grew up in a time when calculators weren't quite as smart as they are now, so I just don't trust them. So I usually clean this up a little bit so it's not so hard for me to type in. So I'm going to leave this 5,000 alone. I usually clean up this thing to just one number. So 0.02 divided by 4 is 0.005 plus 1. So this is going to be 1.005. And then 4 times 10 is 40. And then this thing is a lot easier for me to type into a calculator. So you take this thing, you throw it in your calculator very carefully, and you get your answer. A is in dollars, of course, because we're talking about money, $6,103.97. And it's really just that easy. You just find your information out of the problem, plug it into the equation correctly, and then crank that thing out with a calculator. All right, let's look at one that is compounded continuously. And then I'll go back and talk about the equations a little bit more just to talk about the decay part of it. And then we'll call it good. So it says you invest $10,000. So that's our principal. So we'll write that down. Principal is 10,000 bucks. We are also looking for our interest rate and our time. We don't need n here because it's compounded continuously, so n's not really a problem. All right, our interest rate is 1.5%. So we take our decimal and move it 2 places. So our interest rate is 0.015 and is compounded continuously. This is just telling us which equation to use. So we're going to use A equals P e to the power of RT. And we want to know how much money are we going to have in our account after 7 years. So T is going to be 7 here. So we're just going to plug in these 3 variables to our 3 variables here. And then we're going to throw it into our calculator. So A equals 10,000. E to the power of 0.015 times 7. You could multiply those together if you want. I just threw the whole thing in my calculator like this. And I got an answer of $11,107.10. There you go. So that's how you are going to do your homework. You just read the equation or the problem, pick out the variables that you need, throw them into the equation, and then you're home free as long as you can type stuff into a calculator. All right. Just because I mentioned decay, let's go back and look at this equation. If we look at this, this is 1 plus or minus r over t. The plus is for growth, and this one is for decay. You would use decay if you had something like an exponentially decaying, I don't know, population. You could say something like there are only 1,000 polar bears left in nature, and we lose 7% every year. If you turn this into a minus sign, then plug in the numbers just like you do. Then this turns into a exponential decay function. And instead of stuff growing, what's going to happen is this number, if you have 1 and subtract anything from it, you're going to have a number less than 1. So multiplying by a number smaller than 1 is guaranteed to make your number smaller. So this will go down to whatever 7% of that is, like 980 something polar bears, and then so on and so on. If you want to turn a continuously compounded function into an exponential decay function, what you do is you think about it as your interest rate as being negative 7%. And that's really what you're doing here, is the rate is negative. So this plus or minus comes from your rate. If you are losing things, it's negative 7. So if we put negative there, you're going to have e to, let's say, let's just make this a nice number. Let's say it simplifies to negative 0.2 or something. If you have a negative, one way we can simplify this because of our rules of exponents is 1 over e to the power of 0.2. And because you're turning this into a fraction, you're going to make this number smaller, and it's going to decrease instead of increase. So if you turn your rate into a negative number, that'll turn either one of these into an exponential decay function. But that's not on your homework, so I wouldn't trip about it. And that's your notes. You're done. You're ready to boogie, you guys. So if you have any questions, make sure you let me know. If you're one of those poor kids in like Cambodia who's watching my videos trying to learn math so that you can like make a better life for you people. What do you mean by you people, Barton? I mean, like, you know what I mean. Like, you live in some tiny fishing village and you don't want to live in a fishing village, and you like have some dude download my videos off the dark web and like you study them every night before you go to bed. Good for you. I wish I could come help you, but you know, I'm not going to Cambodia. I'm gonna feel really bad if Cambodia is not like a terrible country. It's probably pretty nice. Cool. All right, I'll see you next video.